Kara Denon from the Ed Institute team. In this video, I will show you why having multiple constraints, or a systems of equation, allows us to determine multiple unknown values. Many of us learned about systems of equations by doing a lot of algebraic manipulation and not much thinking. By stepping back to look at what each equation in a system tells us, and by looking at the relationship between the two equations in a system, we can get a much stronger sense of what is really going on and why systems allow us to tackle problems with multiple unknowns. We are going to look at two examples of systems in this video. In both of them, having multiple constraints allows us to determine multiple unknowns, but there are different types of relationships that allow us to do that. This image is showing 2 tall candles, 3 short candles, and a price tag that says $4.20. This image does not include the price of each tall candle or the price of each short candle. So there are 2 unknowns in this situation. What could the prices of these objects be? Well, I can come up with a couple of possibilities based on this information alone. If each short candle costs $1, then the tall candles would be 60 cents each. If the tall candle cost $1.50, then each short candle would cost 40 cents each. We could come up with many other combinations of prices that would result in a total of $4.20. We do not know which candle is more expensive, so we have no way to narrow down these possible prices. But is there anything else I could say for sure? One thing I would know is that if I wanted to buy double this amount of candles and buy 4 tall candles and 6 short candles, that would double the price. Each set of 2 tall candles and 3 short candles would still cost $4.20. So together, 4 tall candles and 6 short candles would cost $8.40. In fact, I could keep figuring out new prices of new combinations as long as they are made of sets of 2 tall candles and 3 short candles. But doing this does not give me any more information about the price of each individual candle. So now let's take a look at this image. This image is showing another combination of candles at the same store. When we have 2 constraints that deal with the same 2 unknowns like this is called a system. This new combination shows us that 1 tall candle and 4 short candles would cost $4.35. This set of candles could not be created by adding copies of our original set because it is not a multiple of 2 tall candles and 3 short candles. So this gives us new information to work with. Let's look at how this new set compares to the original one. First of all, I know that the price increased by 15 cents compared to the original set when I swapped 1 tall candle for 1 short candle. If removing 1 tall candle and adding 1 short candle increased the price by 15 cents, then the price of 1 short candle must be 15 cents higher than the price of 1 tall candle. Already having 2 combinations tells me about the relationship between my 2 unknowns. The short candle is more expensive. This information I did not have when I only knew the price of 1 set of candles. Now that I know this relationship, there is now only 1 possible set of prices that could work. I can see this by swapping out the other tall candle for a short candle, which would increase the price again by 15 cents. This tells me the price of 5 short candles is $4.50. Now, each short candle must cost 90 cents. There is no other possible price that would fit this new relationship we created. And once I have 1 price for the short candle, I also have only 1 possible price for the tall candle, since it's 15 cents less, so 75 cents. Looking at the relationship between 2 different sets of these types of candles told us about the relationship between our two unknowns. In this case, it told us which candle was more expensive and how much more expensive. And this means that there was only one possible price for each type of candle. Let's look at another example of a system where there is a different type of relationship between the two constraints. 2 books and 4 magazines cost $42. 4 books and 4 magazines cost $72. This situation, once again, involves 2 unknowns: the price of each book and the price of each magazine. Once again, I want to focus on the relationship between the 2 combinations. In this system, both sets of objects include 4 magazines, and both sets contain at least 2 books. So the difference between the costs of these sets of objects, $30, must come from the 2 additional books in the second set. That automatically tells us there is only one possible price for the books, $15 each. But if there's only one possible price for the books, then there is only one possible price for the magazines. If each is $3, that's the only way to get to a total of $42 or $72 with these combinations. This example is different from the last one we looked at. Instead of telling us how the price of each book is related to the price of each magazine, looking at the difference between the prices of the 2 sets instantly showed us that there was only one possible price for the books, and thus only one possible price for the magazines. There are 2 unknown values in all of these situations: the price of each object. With only one constraint, the price of one set of objects, I can come up with many different values or prices. As soon as I had the second different constraint, the price of a second set of the same objects, this narrowed everything down. When we look at 2 constraints with the same unknowns, investigating what makes up the difference between the 2 constraints will either reveal a relationship between the 2 unknowns, or it will help to reveal one of the unknown values. In both cases, this leads to only one set of values that would match both constraints. This is why we say that having 2 constraints or 2 equations allows us to find a solution to a system of equations with 2 unknowns. Once again, I'm Kara Denham. Thank you for watching.